Hi, Point. I have your most recent quiz here. I hope you're doing well. So this one asked you which relation is a function. So when we're talking about function, we have to remember that x values cannot repeat. So as I look at the table you selected, there are two 2's in that table. So that one won't work. In the next table, we have two -8's and two 1's. Okay, so that one doesn't work. This one we have all -5's. That one doesn't work. The only one that works is that last table because none of the x's repeat. Question 4, the equation below models the height in feet of a softball t seconds after it is hit by a batter. Why is the height of the ball a function of time? So function, that means x's don't repeat. So if we were to graph this, and I'll just show you over time what it looks like if you like throw a ball or that a ball is hit by a batter. That's what's happening here. So the ball gets hit, right? The pitch comes in. Let's say we'll put the batter. I'm just going to draw a batter here. There's a bat. So the ball comes in right about here, right? And they swing, and this is what the ball does. Okay, something like that. This is time, and this is height. So the question is, why is it a function? Well, it's a function because time doesn't repeat itself. Every value of time is associated with only one height. Okay, that passes the vertical line test. X's don't repeat in a table, that same kind of concept. Time doesn't repeat itself, or in a particular moment in time, the ball can't be at two places. The ball can't be, let's say this is 1 second. Okay, the ball can't be here, excuse me, and then also be up here at the same time. And it looks like you just maybe have those two concepts flipped, right? So each value of time, so it's the x is associated with one y. Each x is only associated with one y. And when you have x's that repeat, that's not true. Which statement describes how to determine if a relation is a function? So this says if any of the input values are equal to the output, not equal to, repeated. Okay, we don't want any inputs to repeat. Those are your x values. Inputs are the x's. I hope I can drop this down. Whoops. There we go. Okay, Lonnie writes this equation. She wants to describe the equation using the term relation and the term function. The equation represents a relation and a function. A relation but not a function but not. Okay, this can never be true. This one down here, oh, it's going to go away. Every time I try to write, it's going to go away. So let's look at the third option down here. Look at my pointer. A function but not a relation. This is not possible. Everything's a relation. Only certain relations are functions. So this last one can't be it. It also can't ever be a relation. There's always a relation. But in this case, it would be a relation and a function. Again, this is a parabola. When you graph this, it does something like this, or it could go the other direction. It could go like this. You'll notice both of those graphs do pass the vertical line test. So in this case, it is a relation and a function. It does look like you eventually got it right. I don't know if it made you get it right before you went on, because there is a check mark, but it's red. Which statement best illustrates using the vertical line test to determine if the graph below is a function? So I already can tell this is not a function. If I draw a vertical line, it's going to hit 2 times, right? Anywhere I draw, just about anywhere I draw. Those aren't real straight, but pretend like they are. There we go. That's a straight one, right? They hit twice everywhere. So first of all, it's not a function. So it's not that one, and it's not that one. Because the line x equals 0 intersects the graph at 2 points, because the line y equals 0. Okay, so when a line is y equals lines actually go this direction, and x equals lines go this direction. I know that seems kind of backwards because the x-axis is left to right and the y-axis is up and down. There's a little more math behind that I can explain, but here, vertical lines that go up and down, they are x equals lines and not y equals lines. Okay, so hopefully that's helpful. I think, let me go back. Yeah, so I'll send you this, or you watch this video, and then you've got another retake or two on there to do when you are ready. Let me know if you need anything else.